Okay, good morning viewers and welcome to today's lesson in chemistry, Form 1. It's about temporary and permanent changes. Temporary and permanent changes. So, temporary changes are also known as physical changes. Temporary changes can also be referred to as physical changes, while permanent changes are sometimes referred to as chemical changes. So a change is just a variation in form or size or shape, but basically we are going to look at the changes in terms of temporary and permanent, and with that we need to know the characteristics of each of them so that we can be able to identify whether that change is permanent or physical. So the characteristics of physical changes and permanent changes, physical changes and chemical changes. So let's do it in form of a comparison table. We have here a temporary change on my left, temporary change on my left, and then we have permanent change on my right, permanent change on my right. So we have a comparison table like that. So the first characteristic of a temporary change is no new substance is formed. No new substance is formed. No new substance is formed. The first characteristic of a permanent change is a new substance is formed. A new substance is formed. A new substance is formed. For instance, if I hit iodine crystals, solid iodine crystals in a boiling tube, the iodine crystals, upon heating, they will sublime and form iodine vapor. If I trap the iodine vapor using a cool surface, then we observe that the iodine vapor will solidify, the process we call deposition. We shall get back our iodine crystals. So still, that is iodine crystals and iodine vapor, still the same substance, iodine. So there, we are saying no new substance is formed. Another example is when you are heating ice. Ice is water, frozen water, water in solid state. When I heat ice to melting point, that ice is going to melt into liquid water. The ice will melt into liquid water. If I place the liquid water in a container and put in a deep freezer, that liquid water will still freeze and get the ice. So you see that there, the liquid water is still water. Water in liquid state, and ice is water in solid state. Therefore, no new substance is formed. On the other hand, a permanent change is where a new substance is formed. A change in form whereby a new substance is formed. For example, if I take a piece of paper and light it, put it in fire and light it so that it burns, the result of burning that piece of paper is ash. I will get ash. I will get ash. So I have a piece of paper, I will get ash. It changes to ash. Ash is different from paper. As ash and paper is not the same substance. Therefore, in that type of change, we call it a permanent change because a new substance is formed. The other characteristic is the change is easily reversible. The change is reversible. The change is reversible. The change is reversible. Like what I've just said about heating iodine. You heat iodine, solid iodine will sublime to iodine vapor. Then on cooling that iodine vapor, I'll get back my iodine, solid iodine. So there I would have reversed that change from the product, I can reverse and get back the reactants. So such a change is reversible. Also, heating ice. You heat ice, it will melt to liquid water. Then when you place the liquid water in a freezer, it will, after some time, that liquid water will freeze and you get back your ice. Therefore, that change is reversible. While in a permanent change, the change is irreversible. Change is irreversible. Irreversible. Like the same piece of paper I have said, when you hit a piece of paper, you will get ash. You cannot get back your piece of paper from the ashes. So that change is irreversible. You cannot be able to reverse or get back the reactants from the products. Another main characteristic of a physical change is there is no change in mass. There is no change in mass. There is no change in mass. No change in mass. While this one here, there is a change in mass. 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 So when we talk about there is no change in mass and there is a change in mass, for temporary change, we have studied the kinetic theory of matter, which says that matter is made up of particles which are in constant state of motion. Matter is made up of small particles which are in constant state of motion. We have said that in liquid state, in solid state, the particles are closely packed together. That means there is a very strong force of attraction between those particles of the substance. So if the solid has got particles A, B, C, D, E, F, G, H, I, and J, when I hit that solid to melting point, the force of attraction between the particles is going to decrease. So the particles will be relatively far apart from each other. They will not be as close as when they are in solid state. There is some distance between those particles. But you find that here, when it has here, the same number of particles are very closely packed. Here, those same number of particles, there is some space that is within them. So since we still have the same number of particles in each case, all substances A up to J will shall also have in gaseous state, the particles are far apart from each other. We shall still have the same particles A up to J. So since we are having the same number of particles in each case, we don't expect the mass of that substance to decrease or increase. The mass is not going to change because we have seen that for temporary changes, they mainly involve change of state. Change of state from solid to liquid, liquid to gas, gas to solid, gas to liquid, solid to liquid to solid. So since it only involves change of state, the number of particles that are present in that substance do not change, does not change. So it means the mass of that substance will not change. There is no change in mass. For the permanent change, we say that there is a change in mass because in most cases, a permanent change occurs. I'm going to give an example of two types of changes. One is heating copper 2 carbonate. Heating copper 2 carbonate. Heating copper 2 carbonate. Heating copper 2 carbonate. When you heat copper 2 carbonate, it decomposes to form, copper 2 carbonate is green in color. It looks green. Copper 2 carbonate is green in color. When you heat, it forms a black solid. The black solid that is formed is called copper 2 oxide. Copper 2 oxide is a new substance. The mass of copper 2 oxide is less than the mass of copper 2 carbonate because besides the copper 2 oxide, it also decomposes to produce carbon 4 oxide, which escapes to the atmosphere. When carbon 4 oxide escapes to the atmosphere, the remaining mass of copper 2 oxide will be less than the original one. So the mass of copper 2 carbonate. So it means there is a change in mass. And not just a change, there is a decrease in mass in such a reaction. Let's consider an example of heating magnesium ribbon. Heating magnesium ribbon. When you heat magnesium ribbon, it burns with a brilliant white flame, a very, very bright flame, to produce a white powder. The white powder that is formed is magnesium oxide. The white powder is magnesium oxide. The white powder, which is magnesium oxide, is also different from the original magnesium. Therefore, a new substance is formed. Then also, we see that white powder, the mass of that white powder is higher than the mass of magnesium, because magnesium alone and magnesium oxide means magnesium has combined with oxygen. So it's not an element on its own. Something else has been added on it. Therefore, the mass of that has increased. There is an increase in mass, there is a decrease in mass. Both increase and decrease, those are changes in mass. So in a permanent change, there is a decrease in a change in mass, either decrease or increase, as I have explained there. Then, lastly, the temporary changes, they do not involve great heat changes. That is, they are not accompanied by net heat changes. These ones are basically accompanied by net heat changes. Net heat changes. By saying net heat changes, we mean that either the reaction is endothermic. Endothermic means heat is absorbed, heat energy is absorbed, or this one means heat energy is absorbed, and exothermic means heat energy is produced. Heat energy is produced. Heat energy is produced. So those are the main differences between a temporary change and a permanent changes. So however, we still have some temporary changes, some chemical changes which are temporary. We still have some chemical changes which are temporary. For example, heating hydrated copper 2 sulfate. Heating hydrated copper 2 sulfate or hydrated cobalt 2 chloride. Heating hydrated copper 2 sulfate. So when you heat hydrated copper 2 sulfate, heating hydrated copper 2 sulfate. When you heat hydrated copper 2 sulfate, it will produce anhydrous copper 2 sulfate. Anhydrous copper 2 sulfate. Anhydrous copper 2 sulfate and water. It will produce anhydrous copper 2 sulfate and water. When you heat it in a boiling tube, the hydrated copper 2 sulfate is blue in color. There are blue crystals. Blue crystals. While anhydrous copper 2 sulfate is a white powder. A white powder. And then water is a colorless liquid. There is a colorless liquid that is formed on the cooler parts of that boiling tube. So the colorless liquid that is formed is water. So it's a new substance. Here, this hydrated copper 2 sulfate means that copper 2 sulfate contains water of crystallization. Anhydrous copper 2 sulfate shows that this one does not contain water of crystallization. However, if I add water to my anhydrous copper 2 sulfate, I will get back the hydrated copper 2 sulfate. That means this change, despite being a chemical change, it can be reversed. Besides being a chemical change, it can be reversed because by adding water to the anhydrous copper 2 sulfate, I'll get back my hydrated copper 2 sulfate. Another example, we are saying hydrated cobalt 2 chloride. Hydrated cobalt 2 chloride. When you hit hydrated cobalt 2 chloride, you are going to get anhydrous cobalt 2 chloride. Anhydrous cobalt 2 chloride. Cobalt 2 chloride. And water as well. This one means anhydrous is without water of crystallization. This hydrated is pink and anhydrous is blue. Then, of course, water is a colorless liquid. So this one is a temporary chemical change. So the characteristics of a temporary chemical change are slightly different from the characteristics of a permanent change and a temporary change, because in a temporary change, we have said no new substance is formed, there is no change in mass. What else have we said? No new substance is formed, there is no change in mass, it is reversible and does not involve a lot of heat change. For a chemical change or permanent change, we have said a new substance is formed, there is change in mass, there is, it involves a lot of heat changes. It involves a lot of heat changes and it is not reversible. This one, the characteristics of a temporary chemical change are, so temporary chemical changes, temporary chemical changes, temporary chemical changes, temporary chemical changes. One, a new substance is formed. 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 Because we have seen here, the examples we have given, like hydrated copper 2 sulfate, it contains water of crystallization. Anhydrous copper 2 sulfate does not contain water of crystallization. So if a solid contains water of crystallization and the one that does not contain water of crystallization, those are different substances. Therefore, a new substance is formed. Even when I add water to the anhydrous copper 2 sulfate, it will become hydrated. It will become a new substance. The other thing is there is change in mass. There is change in mass. There is change in mass. Because if I hit the hydrated copper 2 sulfate, for example, the water of crystallization will move out. It will lose the water of crystallization. So the remaining anhydrous copper 2 sulfate without the water of crystallization will have a lower mass compared to the hydrated copper 2 sulfate, because the mass would have been, the water would have been lost. If I take the anhydrous cobalt 2 chloride and add water, the mass of anhydrous cobalt 2 chloride is different from the mass of hydrated cobalt 2 chloride, because for me to get this, I have to add water. So it means there is change in mass to get to that one. The other one, heat energy is lost or absorbed. Heat energy is lost or absorbed, because for me to convert this hydrated copper 2 sulfate to anhydrous copper 2 sulfate, I require a lot of heat energy. The process is endothermic. Heat is absorbed, which will break the attraction between the copper 2 sulfate and the water molecules. Then, if I add water, heat will be produced because the bonds, the forces of attraction between the copper 2 sulfate and the water molecules will be building up. Yeah? When forces of attraction between particles are being broken, energy is used up, energy is absorbed. When forces of attraction between particles are being built up, energy is released. So this, in both cases here, either when you are moving this direction, heat energy is absorbed. If you are moving the other direction, heat energy is produced. Then lastly, the change is reversible. The change is reversible. As you can see there, we can get our hydrated copper 2 sulfate by adding water to the anhydrous copper 2 sulfate, or we can get anhydrous copper 2 sulfate by heating the hydrated copper 2 sulfate. So those are the characteristics of permanent and temporary changes. Now, let us look at constituents of matter. Constituents of matter. As we are already aware that matter is anything that has mass and occupies space, and matter exists in three main forms. We have solid, we have liquid, and we have gas, gaseous state. Those are the three main states of matter. We have gone further and classified matter into two main groups. That is, matter exists either as pure substances or as mixtures. We have gone to look at mixtures, we have looked at pure substances, and say that a pure substance is a substance that contains only one kind of matter, while a mixture is a composition of two or more elements which are not chemically combined. A mixture is a composition of two or more elements which are not chemically combined. Now, the constituents of matter, we see that matter exists either as elements, either as molecules or as compounds. Elements, molecules, or compounds. So, elements, an element is defined as a pure substance which cannot be divided into anything simpler, which cannot be divided into anything simpler by chemical means, which cannot be divided into anything simpler by chemical means. That is an element, chemical means. And elements are usually made up of atoms. Elements are made up of atoms. The elements, they are made up of atoms. They are made up of atoms. They are made up of atoms. So an atom is the smallest particle of an element that can take part in a chemical reaction. The smallest particle of an element that can take part in a chemical reaction. That can take part in a chemical reaction. In a chemical reaction. That one is an element. The smallest particle, that one is an atom, not element. An atom, the smallest particle of an element that can take part in a chemical reaction. A molecule is a group of atoms, of an element or compound which can exist independently, independently. This is because we have some substances which cannot exist as atoms. For example, oxygen. Oxygen cannot exist as an atom on its own. Two atoms of oxygen join together to give us oxygen gas. Oxygen gas is made up of oxygen molecules. We have hydrogen molecule, such are molecules. We have carbon dioxide, we have water. Those are examples of molecules. Atoms either of the same element or different elements, they come together, they exist as a molecule. Then we have compounds. Examples of elements here, we can say sodium, we can say carbon, we can say iron, aluminum, and so on. There are so many elements. So compounds. A compound is defined as a pure substance, which is made up of two or more elements which are chemically combined. Two or more elements which are chemically combined. A compound is a pure substance which is made of two or more elements which are chemically combined. So any pure substance that contains two or more elements, that one is called a compound. So from the name of a compound, one can be able to determine, to know the elements that are present in the compound. So the constituent elements of a compound, can be determined from the name of the compound, can be determined from its name, the name of the compound. That is, if the names end in, let me write this other side. If the names end in number one, if the name of the compound ends in IDE, it means that the compound consists of only two elements. The compound consists of only two elements, except for hydroxides. Like if I say sodium hydroxide, does not consist two elements. But if I say sodium hydride, an example, sodium hydride, this is not a hydroxide, therefore sodium hydride, we shall say that compound contains two elements, sodium and hydrogen. Magnesium fluoride, it is IDE, so it contains magnesium and fluorine. Potassium oxide, it is potassium and oxygen. Potassium oxide, IDE. If the name of the element ends in ITE, it means the compound consists of three elements, one of which is oxygen. Three elements, one of which is oxygen. That is barium sulfite, ITE. So barium, sulfur, and oxygen. Because of ITE, this one will contain barium, sulfur, and oxygen. Magnesium nitrite, Nit is nitrogen. ITE, it means that one of those elements is oxygen. Since we have already mentioned magnesium and nitrogen, then obviously the third and last element is oxygen. Nitrogen and oxygen. If the name ends in ATE, if the name ends in ATE, then the compound may contain 3 or more elements, but one of them must be oxygen. Ends in ATE. This is number 3. Ends in ATE. It may contain at least 3 elements, of which one is oxygen. One of which is oxygen. Sodium carbonate. Let me give an example here of sodium carbonate. So you can see ATE. So the elements that are present here are sodium, carbon, and oxygen, because we have talked of one of them being oxygen. Then we have, let me give potassium or magnesium. Let me use calcium because I've used magnesium before. Calcium hydrogen sulfate. We want to see the elements that are present there. We have said at least here meaning 3 elements and above. They can be 3 or more elements. So calcium hydrogen sulfate will contain calcium, hydrogen, sulfur, and oxygen. Those are the elements that will be contained there. So you see, this one ends in ATE. You see, this ATE here, ATE, we have 4 elements. This ATE, we have 3 elements. That's why we were saying at least 3 elements. So from the name of the compound, we can be able to know the elements that are present in a compound. So can we try and give the elements that are present in the following compounds? Number 1, yeah, so I've given here potassium iodide. The elements that are present in potassium iodide are, because the name ends in IDE, and we have potassium here, so it will be potassium and iodine. Iode is iodine. Magnesium hydrogen carbonate, we shall have magnesium, hydrogen, carbon, and oxygen, because this name ends in ATE. Calcium nitride is calcium and nitrogen, because the name ends in IDE. We said IDE consists of only 2 elements apart from hydroxide. This is not a hydroxide. Zinc sulfide. So sulfur IDE shows that it is only 2 elements, zinc and sulfur. Copper 2 sulfate is copper, sulfur, and oxygen. copper, sulfur, and oxygen. So from the name of the compounds, we can see, you can be able to tell the elements that are present there. So today we have looked at the temporary and permanent changes, the characteristics of each of them, and we have also looked at a few cases, examples of such changes. We have also said that we have some chemical changes which are reversible, which we are calling temporary. We have seen the two cases of a temporary chemical change, that is heating hydrated copper 2 sulfate or hydrated copper 2 chloride. We have seen the characteristics of a temporary chemical change. We have also said that the constituents of matter are either elements, molecules, or compounds. An element we have defined as the pure substance which cannot be divided into anything simpler by chemical means. That one is an element. We have gone further and said that elements are made up of atoms. They are made up of atoms. So several atoms, they make up an element. For example, sodium as an element is made up of sodium atoms. Magnesium as an element is made up of magnesium atoms. So several atoms of an element, they make up that element. We have said, however, that we have some atoms which cannot exist on their own. They exist as a group. So groups of atoms of an element or compound, we have called them molecules. Like we have said, oxygen atoms cannot exist on their own. Groups of oxygen atoms come together to form oxygen molecules. Hydrogen molecule, carbon dioxide molecule, water molecule. Compound. A compound, we have said, is a pure substance which is made of two or more elements that are chemically combined. We have said that from the name of the compound, we can be able to know the elements that are present in a compound. We have looked at three main areas where the name can be used. We have said IDE means it's a binary. Binary means it consists of only two elements. Binary means two. So a binary compound is a compound that contains only two elements. So that one is IDE, except for hydroxide. Like if I say sodium hydroxide will be sodium, hydrogen, and oxygen. So hydroxide, oxide is oxygen, hydrogen, sodium hydroxide. So these ones are the ones that will not have only two elements. But magnesium fluoride, magnesium fluorine, potassium oxide, potassium and oxygen. And we have said that if it is ITE, then it means it contains three elements, one of which is oxygen. And let me just finish by saying the ones that end in ITE have less oxygen compared to the ones that end in ATE. ATE has more oxygen than ITE. ATE has more oxygen than ITE. So in our next lesson, we will look at chemical symbols, because chemists usually represent symbols. To use symbols to represent elements. We shall not be writing potassium like that all the time, or magnesium, or sodium. There we shall learn how we can be able to represent those elements using symbols, and then also look at chemical equation. Until next time, I wish you all the best.